Good morning. Today we're going to be doing Advent of Code Day 23. Today I'm going to be doing the two programming puzzles and then explaining their solutions. As always, the code is going to be in the GitHub repository, which is linked down in the description. If you want to see any other day, videos are going to be in a playlist, which is also linked down in the description. So feel free to check those links out. Alright, Day 23, Crab Cups. The small crab challenges you to a game. The crab is going to mix up some cups, and you have to predict where they'll end up. The cups are arranged in a circle and labeled clockwise. For example, if you're labeling where 3, 2, 4, 1, 5, there would be 5 cups in a circle, going clockwise around the circle. Yeah, okay. Before the crab starts, it will designate the first cup in your list as the current cup. The crab is then going to do 100 moves. Each move, the crab does the following actions. The crab picks up the 3 cups that are immediately clockwise of the current cup. They are removed from the circle. Cup spacing is adjusted as necessary to maintain the circle. The crab selects a destination cup. The cup with a label equal to the current cup's label minus 1. If this would select one of the cups that was just picked up, the crab will keep subtracting 1 until it finds a cup that wasn't just picked up. If at any point in this process the value goes below the lowest value on any cup's label, it wraps around to the highest value on any cup's label instead. The crab places the cups it just picked up so that they are immediately clockwise of the destination cup. They keep the same order as when they were picked up. The crab selects a new current cup, the cup which is immediately clockwise of the current cup. For example, suppose your cup were labeling were 3, 8, 9, 1, 2, 5, 4, 6, 7. If the crab were to do merely 10 moves, the following changes would occur. And it does that? Okay. In the above example, the cups of values are the labels as they appear moving clockwise around the circle. The current cup is marked with parentheses. After the crab is done, what order will the cups be in? Starting after the cup labeled 1, collect the other cups' labels clockwise into a single string with no extra characters. Each number except 1 should appear exactly once. In the above example, after 10 moves, the cups labeled clockwise from 1 are labeled 9, 2, 5, 6, 5, and so on, producing this number, so 1 is not included. If the crab were to complete all 100 moves, the cup order after cup 1 would be 6, 7, 3, 8, 4, 5, 2, 9. Using your labeling, simulate 100 moves. What are the labels on the cups after cup 1? Okay, so seems pretty simple. Just a standard simulation problem. So I'm going to solve it and then explain it. Okay, so we have arrived at our first answer. Sure enough, it does not contain a 1. So this is our answer, and it's correct. Okay, so let's explain. So this is a pretty simple problem, I think. It tells you exactly what you need to do, and that's exactly what I did. I didn't do any optimizations. It still ran incredibly quickly, though, so I guess just doing it the lazy way works. So first we read the input from our file, as normal, and then we define a function to actually simulate a move given the current order of the cups, as well as the current cup. We represent cups as a list of integers, and we represent current as just a label of the current cup, not as the index. And I thought using labels would be easier because indexes, like when you have stuff looping around and stuff being removed all the time, it's a pain, and I didn't want to deal with that. So current is an integer, it's the label of the current cup, and cups is a list. It returns the new order of the cups as well as the new current cup after we do a move on this, so this just simulates a move. So first we define the length of the cups as n, just to make it a little bit easier to wrap around indices. Next, we want to pick up 3 cups, right? We want to find the 3 cups that are immediately next to the current cup, and we're saying moving to the right, increasing indices is clockwise. So we do cups.index current because we want to find the index of the current cup, and then we want to place it. We want to take the 3 cups that are immediately after the current cup. So we do take the index right after the current cup, and then we also have to take it mod n, just because if it goes over the end of the array, then we want to loop backwards, and we don't want to do an additional if statement for that because we're lazy. So we repeat 3 times. We take the cup that is at index, and then we increment index by 1, looping it around as necessary using this modulo operator. And we just append that to our picked up list, which describes the cups that are picked up in a list of integers. So then we want to remove the picked up cups from the actual list of cups. So we looped through the picked up list and we removed all of those from our total list of cups. Then we set our destination. We want to find our destination cup, and that's right here. No, that's right here. Destination cup. The label is equal to the current cup's label minus 1. So current is the label of the current cup. We subtract 1 from that. If it's not in... So while it's not in the list of cups, we want to decrement it by 1, because that's what it says over here. Keep subtracting 1 until it finds the cups that wasn't just picked up. If at any point it goes below the lowest value, so min cups is the lowest value on any cups label, then it wraps around to the highest value. So it wraps around to max cups. That's the highest value in our list. So now we have a valid destination cup. This is the label. We find the index of the destination cup, and we also want to find the index where we should insert the picked up cups. So to insert that, we take the left half of the list up to the insertion index. We add the cups that we need to insert, and then we add the rest of it. So it's kind of like taking a list, splitting it in the middle, and then putting stuff in the middle. And that's how we insert the picked up cups. And then after that, we also want to find the new current index. The new current index is just the, how do we do that? It's the cup that's immediately clockwise. So we find the index of the current cup, we add 1 to that, and that's the index of the new current cup. Also, throughout all of this, we need to take the indices mod n, just to make sure that they're not out of bounds. Just to make it a little bit easier. After that, we just return the new cup order as well as the new current cup. And remember, current cup is a label, so that's why we take the index of the current cup. Okay, so after that, we just parse our input by turning it into a list and then turning that into a list of integers. And then we describe our current cup as the first cup in the list. Then we repeat 100 times, we simulate a move, and then we assign the result of that move to our variables. And then after that, we remove the 1, and then we just join it all together. So that's it. Yeah, pretty simple. Okay, time for part 2. Due to what you can only assume is a mistranslation, you are quite surprised when the crab starts arranging many cups in a circle on your raft, 1 million in total. Your labeling is still correct for the first few cups. After that, the remaining cups are just numbered in increasing fashion, starting from the number after the highest number in your list and proceeding 1 by 1 until 1 million is reached. For example, if your labeling were 54321, then the cups would be numbered 54321 and start counting up from 6 until 1 million is reached. After discovering where you made the mistake in translating crab numbers, you realize that the small crab isn't going to do merely 100 moves. The crab is going to do 10 million moves. The crab is going to hide your stars, 1 each, under 2 cups that will end up immediately clockwise of cup 1. You can have them if you predict what the labels on those cups will be when the crab is finished. In the above example, this would be 934001 and then 159792. Multiplying these together produces this big number. Yikes. Okay. Determine which 2 cups will end up immediately clockwise of cup 1. What do you get if you multiply their labels together? Okay, so we're going to have to do a little bit more optimization here. Yeah. Okay, let's get to it. Alright, we got our answer. It is this humongous number over here. Let's see if it works. I don't know if it will. It's not the right answer. It's too low. Okay, so I think we should try the example. Okay, we have arrived at our answer. It is this ginormous number over here. Yeah. Okay, it's correct. Okay, so let's explain this. I will need to draw this out. So, 1 second. Alright, so we're going to need to use a little bit different of a strategy from part 1. But it's the same idea. We just need to run faster. So, I'll explain the code in a bit, but I'll explain the basic idea right now. So, first, let's get an example. So, our example is 389 125 467. Okay. 389. Hang on. What? 4 6. The heck? Okay, weird stuff is happening. All right. So, we have our numbers, our cups in a circle, right? So, what we need to do is we actually need to create something like a linked list. And if you don't know what a linked list is, I'll explain it. So basically, there's usually a linked list has a head, but in this case we're going to do a circular linked list, so it doesn't really have a head. But we'll say first element in the linked list is 3. The next element is 8, and then 9, and then 1, and then 2, and then 5, and then 4, and then 6, and then 7. And then 7 goes all the way back to 3. So we can also represent it in the circle just by drawing arrows. And the utility of a linked list comes from its ability to get the next element in the linked list rather quickly, and also being able to access any element in the linked list at any time. And this is particularly useful for this problem because we need to be able to access like random elements in this linked list, any of them at any time, but we also need to be able to access the next element in our linked list. So we're representing the circle as a linked list, okay? And the linked list, the idea is just what I described here. We can access any element. So if, for example, we want cup 8, then we can directly go to cup 8 in like instantly. We don't have to do any looping or anything. We just go instantly to cup 8, and then we can access everything that's ahead of cup 8. We can access its next element. We can access its next element, and so on. So what is our algorithm? Well, actually, first we're going to represent our linked list as a list in Python. So we have our linked list is going to be called next cup because it represents the next cup given a certain cup, and we abbreviate this to NC just so I didn't have to type it out more. So we say NC of 3 is equal to 8, NC of 8 is equal to 9, and so on, and then NC of 6 is equal to 7, and then we loop around so that NC of 7 is equal to 3. So this is pretty interesting, right? Because if we turn this into an actual list, it doesn't really make much sense. I guess we have 3 here. We have 8 here, we have 9 here, we have 7 here, we have 3 here. It just doesn't really make a lot of sense if you just go through the list linearly, but it does make sense if you treat indexes as values, and then if as elements in the linked list, and if you want to find the next value in the linked list, that is just the value of that element. So this is our syntax for our linked list. We're going to use a list. All right, so it's basically like the same thing as before. So I'm going to get rid of all these useless print statements because we don't actually need them. Okay, so we're still going to need to simulate a move, but this time we don't take in the order of the cups because that would take too long. That would be too slow. We just take in the current cup. And the current cup, for example, in this example, starts out as 3. So this is current. Okay. We still have a removed list as well as a destination. So we're going to go through the steps one by one. First, we need to look at the 3 elements right next to the current element. And to do that, we have a list of removed. So remove starts out as an empty list. Current is 3, so we go to the next element in the list by using NC3, and we get to 8. So removed becomes 8. After that, we just repeat this process 2 more times. We go to the next element. NC of 8 is going to be 9, and so this becomes 8 and then 9. And then the next element of 9 is 1, so it becomes 8, 9, 1. And this is what remove becomes. So we kind of need to like get these out of the list, so I'm just going to redraw this. 3, 8, 9, 1, 2, 5, 4, 6, 7. So we kind of need to cut these out, and we already have them stored inside our removed list, so we don't actually need to keep track of them. But hang on, it is weird. Okay, so we need to remove these somehow, and we just remove them. Their relative order is still stored in our linked list, however, so the NC of 8, 9, 3, they're still there. They're still there. We still know that 8, so inside our linked list, 3 still goes to 8, 8 still goes to 9, and 9 still goes to 1, and 1 still goes to 2. So what we basically need to do, we cut them out, so we kind of just say goodbye to these. Their order is still there, so we still know that 8 goes to 9 and 9 goes to 1. But we cut them out, and then we say 3 will go directly to 2. So instead of 3 going to 8, we're going to move that connection and say NC of 3 is equal to 2. So that's what we do over here. Oh, We have a remove list. We just get the next element to the current, and then do that twice more. And then after that, we look at the current, which is 3 in this example. We go to the next element next to the last element in our remove list. So in that case, that's 1. We know that 1 goes to 2. So instead of 1 going to 2, we say 3 goes to 2. So the next element of our current should be actually the next element of our remove list. After that, we want to find our destination. And this is where the real power of linked lists comes in. Our destination cup starts at 3. So this is actually our current cup is equal to 3. Okay. Current cup is equal to 3. We subtract 1. So destination is equal to current minus 1, which is equal to 2. And we keep subtracting 1 while it's like not part of the non-remove list. So while the destination cup is still in removed, this is what the problem just tells us to do. It tells us to not select one of the cups that was just picked up, so we can't have it in removed. We subtract 1. If it goes to the minimum, if it goes below the minimum possible value, which is actually 1 in this case, then we need to set to the highest possible value, which is n. So that's what this is for. You may notice that this expression is a little bit complicated, so we'll just go over it. So current minus 1, this is what we want to set destination to initially. After that, we want to make sure that it's not 0, because 0 is not actually a valid label for any cup. So in this case, I could actually just do that. If destination is equal to 0, then it should go to the highest value cup. So, oh, actually, no. You know what I could do? Here, I could do it like this instead. So while it's removed or it's 0, we want to make sure it loops around. If it's in removed, then obviously we want to subtract 1. But if it's 0, then we want to loop it around. So this should still produce the same answer. I'm pretty confident it will, but let's just make sure that it does produce the same answer. No. Okay, so hopefully that'll produce the same answer. Okay, after that, we want to put our remove cups back next to the destination cup. So in this example, we know that destination cup is 2. So let's just take this thing over here, and let's copy it and paste it. Okay. So now it's over here, all right? So we have set 3, the next cup to 3 to be 2. We still preserve our order inside our linked list. So 8 still goes to 9, 9 still goes to 1. We know our destination cup is 2, so this is destination. We also find the next cup to our destination, which is 5. So we want to say, okay, 2, we'll just put it in this order, a little bit backwards, but that's fine. So we want to say 2, okay, well, 2 now needs to go back to 8, because we want to insert it in the middle there. And then 1 should go back to 5. So in this case, it becomes 3, and then 2, and then it goes 8, 9, 1. This is our remove list. And it goes back to 5, 4, and the rest is preserved. And how we do that, once we have our destination thing, once this loop is done executing, then we find the next cup to our destination cup. In this case, that would be 5. We want to assign the last value of our remove list. That next cup is going to be 5. So in this case, our last removed cup is 1. 1 is going to have to go back to 5 because it's the last element in our remove list. Then we set the destination cup's next cup to be our first cup in our remove list. So for example, our destination cup is 2. We want to set 2 to be able to be equal to 8. Next cup of 2 to be equal to 8. Just to insert it properly in there. After that, we can just return the next current cup, which is equal to just the cup that is immediately clockwise of our current cup, which is just the next cup of our current cup. So notice that the power of linked list in this example comes from our ability to randomly access any cup at any time. So this is like the destination cup. This makes it, linked lists make it really easy to find the destination cup because we don't have to go searching for it around the whole list. That would be really slow. We can just directly access it because it's implied. It's implied in there. Okay, after that, we have our function. Our function is done. This is the hard part. Now we have the easy part, which is just initializing the list. First, we declare an n, which is 10 to the 6, just to make it a little bit more generalized. 10 to the 6 is the number of cups we have. That's going to be n. Then we have our next cup big array, and this array just needs to be able to store keys, which are labels of cups, and their next cup, which is the value. In this case, we're going to need an array of size n+1 because we need to be able to access the next cup of n. We need to be able to assign that and read that. So we need to be able to use the key n, and in that case, we're going to have to make our array size n+1. Otherwise, it's not going to be in bounds. Okay, cups. This is the same line we had in part 1, right here. Okay, so within the cups, we loop through the first length cup -1. So in this case, that's up to 1. So 6859742 For each of those, we assign the next cup to a given index to just the cup at the next index. So 6 would be 8. Next cup of 8 would be 5. Next cup of 5 would be 9. So on. Next cup of 2 would be 1. Next cup of 1 would be 3. Now, next cup of 3, the problem tells us to assign that to the next highest possible value. So in this case, that would be 10. So next cup of 3 would be 10. And that's what this line over here does. It takes the maximum value in our cups array and then adds 1 to it and assigns that to the next cup of the last cup in our given list. After that, we just go through and assign 10 to 11, 11 to 12, 12 to 13, and so on up to 1 million minus 1. And then 1 million needs to go back to the beginning because it's a circle. So 1 million goes back to, in our case, 6. After that, we just assign our current cup, and then we do the loop 10 to the 7 times. We can actually verify if it worked. Yes, I think it did. Wait. Yes. Okay, so it worked. That was just the thing with the destination cup back then, but it worked. So we assign our current cup to the first cup in our list, and then we just go do the simulation 10 to the 7 times, reassigning the current cup because that's what determines a move. And then we just find the next cup to 1, so 1 cup's next cup, and then the next cup of that. So the first and second cups immediately to the right of 1. We multiply those together, and then we are done. So that's it for part 2. All right, so thanks for watching this video. Hopefully it helped. As always, if you have any feedback, feel free to post a comment or DM me on Discord. If you want to check out the code, that's going to be in a GitHub repository, which is linked in the description. Actually, okay, so it is now pushed to GitHub. The link is down in the description. So, as always, hope this was helpful. We're getting pretty close to Christmas. There's only 2 days left. So, yeah, thanks for watching, and I'll see you tomorrow with day 24. Goodbye.